Assalamualaikum and hello everyone. We are Group 8 from Mechanical Engineering. Today, we will demonstrate our project, the Smart Indoor Comfort Monitoring System using Arduino Uno. This system monitors temperature, light intensity and moisture level, and automatically controls LEDs, a fan and artificial lighting with a manual override option. Each team member will explain their respective module followed by a demonstration of their part.
So hi, I'm Nick, and my role was to integrate the temperature and humidity sensor, also known as the DHT22, but in our case, the Tinkercad doesn't support this sensor, so we will be using two alternative sensors. The first one being the temperature sensor, TMP36, and also a soil moisture sensor as a substitute towards the humidity sensor of the DHT22. Okay. So to start off, we'll be having a temperature sensor right here, okay, and it will be the V out pin will be connected to the A1 pin of the Arduino, while the power pin of the temperature sensor will be connected to the V5 pin of the Arduino, and the ground pin will be connected to the ground pin of the Arduino, labeled as black. And then in our code, let me show you right here, we have set the threshold for the temperature sensor. So any temperature below 20 Celsius will be considered as cool, okay? And then any temperature above 28 Celsius will be considered as hot, and anything between them, 20 to 28 Celsius, will be considered as comfortable. So these ranges are important because they determine which LED lights up and whether the fan is turned on. So just a quick demonstration right here. So this is the LCD panel to show us the temperature current right. So right now I'll be having 24.8 Celsius of it. It is between the range of 20 to 28, so it is comfortable, and the green light will light up. So what if I turn it down? So if I turn it down, we'll have negative 11.9 Celsius, which is way below 20 Celsius. And now it is too cool, so the yellow light will light up. And if it's too hot, for example right here, we have 70.2 Celsius, which is way beyond 28 Celsius. So if it's hot, the red LED will light up, and so as the fan will also turn on. So that will be all for the temperature sensor. So moving on, right here you will have the soil moisture sensor as the humidity sensor. So this sensor, the signal pin is connected to A3 of the Arduino, and the power pin, labeled as red, will be connected to the V5 pin of the Arduino, and lastly the ground pin, which is labeled as black, will be connected to the ground pin of the Arduino. So I have all this wired up right here, connected to each other to the breadboard and back to the audio. So after covering that, let me show you the code. So in our code, we have set the threshold for the soil moisture sensor. So anything below 300 moisture will be considered as dry, and anything beyond 700 moisture will be considered as wet. So anything in between 300 and 700 will be considered as humid. So this is also indicated by the LED light that we set up here. So in this simulation, I show you. So currently our humidity is only at 3, which is very dry. So the red LED will light up, and if we turn this up a little bit, we will have a humidity of 444. So in this case, the yellow light will light up because it is humid, and if it's too wet at a humidity of 876, it's considered as wet, and the green LED will light up. Yes, and this is all for the soil moisture sensor and also the temperature sensor just now. Thank you.
Hello, my name is Danya binti Zaid and I am in charge of the light sensor integration. My responsibility was to integrate the LDR light sensor on analog pin A0. The sensor gives values from 0 to 1023 depending on the brightness. In auto mode, if the light level is low, the system increases the brightness of the artificial light. If it is bright, the system reduces brightness in order to save energy. Now I shall start the demo. I will now adjust the LDR sensor in Tinkercad. First, I will lower the light level to simulate the darkness. And as you can see, the artificial light will brighten automatically. And now I will increase the light level in order to simulate daytime. And now you can see that the artificial light will start to become more dimmer.
Okay, let's move to the temperature LED and fan control. I use need temperature readings to control 3 LEDs. Red for hot, yellow for cool and green for comfortable. When the temperature is hot, the fan on pin 5 automatically turn on. If it's cool or comfortable, the fan stay off. Let's demonstrate. Using the same temperature adjustment as Nick, I will highlight the actual response. Okay, first hot. In about 30 degree Darjah Celsius, red LED will on and fan will also will on. And next is cool. In about 50 Darjah Celsius, yellow LED will on and fan will off. And last is comfortable. In about the 25 degree Celsius, green LED will on and fan will off.
I am Sophie, and now I will explain the manual override and light control part of this system. So I implemented the manual override function with a slide switch connected to this light switch connected to pin number 4 through the blue colored line. So in auto mode, the artificial light is controlled by the LDR, while in manual mode, the light is forced to full brightness regardless of the light conditions. Now I will show you the simulation. So now the LDR is now the LDR is at the low level. I lower the LDR level and the light brightens automatically. And if I increase the LDR level, the light will turn off. But if I switch on, which now I will move into the manual mode, if I switch on the switch, regardless of the light intensity from the LDR, the light bulb will still in high intensity.
Hello, my name is Muhammad Akmal Hamdan, and my role was to display all sensor reading and status on an I2C 16x2 LCD, as well as the serial monitor. When the system is first powered on, the LCD displays the message "System Starting" for 1.5 seconds to show the user that initialization process is in progress. After that, the LCD shows real-time sensor data in a compact format. T is for temperature in Celsius, measured to 1 decimal place. H for moisture, sensor reading 0 until 1020 and 23, representing humidity level in our system. L is for light level from the LDR sensor. MA is mode indicator. M for manual override active, and A for automatic mode. F on or F off is fan status. F on when the fan is running, F off when it is off. The same information is also printed to the serial monitor for debugging and logging purposes.
Hello, my name is Zahil. My job was to integrate all modules into the setup and loop functions so that each sensor is read, each actuator responds, and the display is updated continuously. I will now run through the full system to show how all components work together. Temperature changes trigger LEDs and fan as expected. Moisture changes trigger the moisture LEDs. Red for dry, less than 300. Yellow for 300 to 700. Green for more than 700. Light sensor and manual override respond as programmed. LCD and serial monitor update all readings in real time. That concludes our presentation and demonstration of the Smart Indoor Comfort Monitoring System. Thank you for watching.